what we're looking at right now is going to be the area of circles. And when we look at area, we're looking at square units. So I put this circle on top of this grid where we have these squares. Now, if I did this with a rectangle or a square, we could actually start counting the squares. And if I look here, I could actually start counting some of these squares. I could go all the way through just counting them. But the problem is those are just the complete squares there that I counted. They're the ones where I can see a full complete square, but then the circle gives me a lot of partial squares. So if I say, okay, maybe this one's like 17, 18, that's close enough. Okay, I'll say that's 19, 20, 21, 22, 23, 24. But still, I have this little area off of to here. So if I say, well, those two maybe make one square. So I can say that's 25. Okay, those two, that's 26. Those two, that's 27. Those two, it says 28. So I could say maybe it's 28 units squared by just looking at the squares. But this, first of all, is not a fairly accurate measurement because when it came to really the red and the blue, I'm making a guess. And putting on that little grid and that for all circles isn't practical. So we do have this formula. The formula is pi equals the radius squared. And for pi for today, in these problems, we're going to use 3.14. And so when I have this, I need to get the radius. Well, the radius is the middle of the circle from the edge. So if I look here, that really became the middle of my circle. That's right there in that middle. So then I just draw my line going from the middle to the edge. And I look, I go 1, 2, 3. So my radius is 3. So I can go the area is 3.14 times 3 squared. Well, that's 3.14 times 9. Now I get 3.14 times 9. I get 28.26 units squared. Now if I look, my guess actually was pretty close, but I was a little bit off because you only get those partial parts of those circles. Or those partial parts of those squares. So you want to really use the formula. So let's take a look at a few more examples using the formula. So the first thing I notice here are my directions. Is with these, it says, oh, round to the nearest hundredth. So the nearest hundredth really means 2 places after the decimal. So I'm going to put my formula again, pi times the radius squared. Well, here it did give me the radius. So I do have the radius. So that's 3.14. The radius is 4, which is 4 squared. Well, that becomes 3.14 times 16. Because 4 squared is 4 times 4, which is 16. And I get 50.24 inches squared, and that's a square unit. And since this is 2 places behind the decimal, I already have it to my nearest hundredth. Now when I look at this next one, they gave me the diameter. They gave me the distance going all the way across. Well, I only really want that measurement from the middle to the edge. Well, that's half of it. So that really just becomes 21. So my area becomes 3.14 times 21 squared. which I'm going to put 3.14, and if I go through the calculator and put it in there, I get 441, because that's 21 times 21. Then the 3.14 times the 21 gives me 1,384.74, and this time it's yards squared. Now I come down here, and now, again, here, they give me ones where I have a decimal. Now again, I'm going to use the formula area equals pi times the radius squared. Now again, I only want for this one this distance. I only want that radius. So I'm going to go the area is 3.14. And when I take 5.6 and I divide it by 2, I get 2.8. So I get the 3.1 times 7.84. Multiply those two together. I get 24.6176 centimeters squared. Now here's where it's the nearest hundredth. So I want two places behind the decimal. So I want the 24.6, but I need to figure out, is this going to be a 1 or a 2? Well, I look behind that 1, I see it's a 7. Since it's a 7, I need to round up 24.62 centimeters squared. Now for the last one here. I have, now they did give me the radius. So I'm going to go, the area is 3.14 times 7.1 squared. I go 3.14, the 7.1 squared, which is 7.1 times 7.1 is 50.41. Multiply those two together. I get 158.2874 meters squared. Again, it says the nearest hundredth, which is two places behind the decimal. So I have 158.2. I look behind the 8. I see it's a 7. So that comes up to 9. And that's 158.29 meters squared. Okay, the last one is a story problem. It says the archery on a bullseye on an archery target has a radius of 3 inches. The entire target has a radius of 9 inches to the nearest tenth. So the nearest tenth tells me one place behind the decimal. Find the area of the target outside the bullseye. Well, this area right in here, that's the bullseye. And the area around the outside here, that's all the area outside the bullseye. What I almost think of this as is kind of a donut problem. Because I want the outside, I need to remove the middle. So the first thing I'm going to do is I'm going to find the area of the target. So I'm going to find the area of the target. So I'm going to say, well, that's equal to 3.14 times 9 squared, because the radius of the target is 9 inches. So that's 3.14 times the 81. And I get 254.34 inches squared. Now I know it says round to the nearest tenth, but I'm not going to do that until I get to the very end of my problem. Now I want the area of the bullseye. The area of that pink circle there in the middle. So this becomes 3.14 times that has a radius of 3, so that's 3 squared. So that's 3.14 times 9, which is 28.26 inches squared. Now what I'm going to do at the end is now to find that other outer area, I'm going to remove this. It's going to like I cut this out, so I'm going to remove it. So the way I remove it is with subtraction. So I have 254.34. Now I'm going to subtract 28.26. Well, I need to end up borrowing. So that becomes 2. This becomes 14. So that's 8. That's 0. Okay, again, I need to borrow or regroup. So I take from the 5. Okay, now that's 14 minus the 8. So that gives me the 6, 2, 2. Now I'm at the area where I want my answer to the nearest tenth. So I looked at tenth as one place behind the decimal. That's 226 points. Well, because the number behind the 0 is larger than 5, I'm going to increase that. That becomes 226.1 inches squared. And that gives me the area of that whole yellow area because I basically removed it. That is what you can do and stuff dealing with and finding the area of circles using that formula.